Jamb 2026 candidate, welcome to today's lesson. Please grab your pen and your notebook to jot down whatever you understand in this lecture. We are moving very, very fast. We have to finish this syllabus before this week ends. All right, so let's go. We are looking at general properties of metal. If you need this lesson note, this short, concise lesson note straight to the point, send me a DM. How do you get my phone number? Look at the comment section. You are likely going to see my phone number there. You can alternatively go to my profile on my bio. You are going to see my phone number there. So ensure you get this lesson note and prepare for your Jamb Smart. This is not the time to start reading textbooks. If you are reading textbook right now and you have not been preparing since last year, November or December, you are in big error. So don't put yourself in such situation. Don't put yourself in such predicament. Come, let me help you. Get my lesson notes and fire down, blast your Jamb UTME. Come back to show me gratitude. Carry goods, come for me. Carry car, come for me. Carry cars, carry houses, carry landed property. Come and give me. I deserve all of them. Let's go. General properties of metals. What are the general properties of metals? They are good conductors of heat and electricity. Why? Because they have free mobile electron. They have free electrons that can move. That's what is meant by free mobile electrons. All right. Though they are solid, but they have free mobile electrons. All right. So they are malleable. What's the meaning of malleability? They can be what? Folded into sheets. You can fold metal into sheets. Can you fold oxygen into sheets? You think on now bend oxygen like this, bend down, hammer right here, hammer right here. No, nah, that's a non-metal. But you can do that to metal. You can fold it into sheets. That's why you have aluminium roofing sheets, zinc roofing sheets. You can fold it. All right. So metal can be what? Can be hammered into sheets. All right. Metals are also ductile. Okay, they are ductile. Okay. What does it mean that a metal is ductile? The metal can be drawn into a wire. That's why you can see copper wire. That's why you can see aluminium wire. Let's go. So they are lustrous. They are what? They are lustrous. They are shiny. Shiny appearance. They are used for what? For ornaments. Okay. They are ornamental. They are used for what? Decoration, aesthetics. All right. Another property of metal. They form basic oxide and ionic salt. Metal forms what? Basic oxide and ionic salt. Remember, basic oxide forms from when oxygen combines with what? Metals. All right. What is another property of metal? They tend to lose electrons and form what? Cation. Okay, remember, metals are highly electropositive. Okay, they lose electron. They are the one that lose electron. Okay, they donate electron because they are reducing agents. Okay, they donate electron and become what? Highly positive. Cations. Okay, cations positively charged. Okay, anions negatively charged. Let's look at alkali metals. The alkali metal that we are looking at here, as suggested by Jamb in her syllabus, is sodium. All right. And since we are looking at sodium, we are taking sodium hydroxide as the first, as indicated by Jamb. Okay, what is the production of sodium hydroxide? How is sodium hydroxide formed? How is sodium hydroxide manufactured? Sodium hydroxide is manufactured through the electrolysis of brine, also called the chlor-alkali process. It is called the chlor-alkali process. What happens during the chlor-alkali process? You are going to get precipitates of hydroxides of aluminium 3 ion, zinc 2 ion, and lead 2 ion, or plumbate 2 ion. Remember, the Latin name for lead is plumbado. That's why you see it as Pb. Okay, that's why you see it as what? Pb. All right. So what are the uses? What are the uses of sodium hydroxide or caustic soda? The common name is caustic soda. All right. It is used in soap making, a process called saponification, making of soap, whereby you react sodium hydroxide to what? To ester. Okay, to form what? Propan 1,2,3 triol and soap. All right. So it is used in paper industry. It is used for neutralization. That's reaction reactions to form salt and water. That is used to make salt. It is used to precipitate what? Metallic hydroxides. What are the metallic hydroxides you use sodium hydroxide to precipitate? They include the aluminium 3 ions, the zinc 2 ions, and the lead 2 ions, or the plumbate 2 ions. Now, let's look at sodium triisocarbonate 4, which is washing soda, and also sodium hydrogen triisocarbonate 4. How are they formed? How are they formed? They are formed through the Solvay process. They are formed through the what? Solvay process. Solvay process is an industrial process used to manufacture sodium triisocarbonate 4 washing soda, and also sodium hydrogen triisocarbonate 4. One forms before the other. Okay, one forms before the other. Which one they form first for the Solvay process? The sodium hydrogen triisocarbonate 4. And the sodium hydrogen triisocarbonate 4 is further oxidized to form what? Washing soda, which is sodium triisocarbonate 4. Now, let's look at the properties of sodium triisocarbonate 4. It includes that it is an alkaline solution. It's an alkaline compound. It reacts with acid to form carbon 4 oxide. Remember, when you react acid with triisocarbonate, sodium triisocarbonate, salt and water is formed. But the difference is that it's not a neutralization reaction, but salt and water is formed. Why is it not a neutralization reaction? It is not only salt and water that are formed. Carbon 4 oxide is also evolved. Look at it. Carbon 4 oxide is liberated. So remember the definition of neutralization. Acid reacts with base to form salt and water only. Immediately any other substance form or any other compound or element forms together with that salt and water, just know that it is no longer referred to as a neutralization reaction. What are the uses of both? For sodium triisocarbonate 4 washing soda, it is used in the manufacture of glass. It is also used in water softening. Most of the time, it is used to soften permanent hard water. But that doesn't mean that washing soda cannot soften temporary hard water. Washing soda can soften any hardness of water, whether temporary or permanent. Washing soda can soften it. All right. So sodium hydrogen triisocarbonate 4 is used as baking powder. You know that it decomposes when you heat it. It's an unstable salt. When you heat this salt, it decomposes to form what? It decomposes to give out carbon 4 oxide. It gives us this component. Okay, this component, when it gives out that carbon 4 oxide, as that carbon 4 oxide is trying to escape from the already mixed glow. Okay, I don't know. Okay, you might not be familiar with glue. Let me say, you know, in a bakery, when, let me say, they want to make bread, for example. Okay, they mix the flour. Okay, that is called glue. Okay, when you mix the flour, it's called glue. That glue, when you add this sodium hydrogen triisocarbonate 4 to it, remember, it's an unstable salt. Okay, when you now take it into the oven, the bread first small like this. So it's small like this. When you take it into the oven, when you heat it up, due to the decomposition of this sodium hydrogen triisocarbonate 4, carbon 4 oxide is released. And as that carbon 4 oxide is trying to escape from that glue, that bread, that already mixed flour, what happens? It go rise like this, boom. Now make, if you look bread, you will see something like ho inside bread. Why? You are seeing that hole inside that bread because it is that carbon 4 oxide that is trying to escape, okay, from the decomposition of this sodium hydrogen triisocarbonate 4. That's what is giving that hole. Now through those carbon 4 oxide, they escape. All right. And as the carbon 4 oxide attempts to escape, the bread go come rise. So they put small bread inside oven. But when the bread done, they can't get big bread. I know you like bread. Sodium hydrogen triisocarbonate 4 is also used as mild antiseptic. What is antiseptic? Against life. Against what? Life. What kind of life is septic life? Septic life is micro life. All the life that exists in the micro world. All the life that exists as microbiology. Okay? All the life that exists in micro world. Fungi, they there, bacteria, they there, all those microscopic life. Okay? Microscopic life, that's antiseptic. So when you say antiseptic, it's against microscopic life. As simple as that. A, B, C, D, easy peasy, shikina. Now, let's look at sodium chloride. It's a normal salt. We know it. That sodium chloride is a normal salt. We use it at home, especially the iodized sodium chloride that helps prevent goiter. Okay? It helps prevent what? The development of hyperplastic goiter. It's also used to what? To treat hyperplastic goiters. Okay? Now, what is the occurrence of sodium chloride? It occurs in sea. Now, for inside sea, that they harvest the salts where we use. Inside sea, now that they go, they carry those salts, they come. Okay? It also exists as rock salts. You find it in seawater, under sea, you will see and there. Sodium chloride also exists as what? Rock salt. Jamb say make we know all these things. Anything where you see for my notes, you don't know say now waiting Jamb want, maybe you know. Now make my notes short. So now all the things where Jamb wants, where Jamb use their man, toss say, learn this one, learn this one. Now here we go from set. Now here we go from set. Now the day inside my notes. Now I make no use any of the content in my notes play. Now from any side you will see question. Alright? So it is very easy. So put everything inside your head. What is the economic importance of sodium chloride? It is a source of sodium hydroxide. They use it until they make sodium hydroxide. It is also a source of chlorine. It is also a source of chlorine. It is also a source of hydrogen. So all these elements and compounds can be made from what? Sodium chloride. Remember, sodium chloride is also a source of what? It's also a source of nutrients. Okay, dietary nutrients. All right. So let's look at the uses of sodium chloride. It's used for seasoning food. It is used for preservation. The one they call salting. That's why when you eat bonga, when you chop bonga, you chop bonga like this, you will know say salt they inside, they add salt journal. That salt is preservative. It's called salting. Okay. In the olden days, Nana said they only to put too much salt. For olden days, where preservation never to make sense. If you see the kind of salt that they pack for all those things, to help, you know, increase the shelf life. So to prolong the shelf life. So if you can't put that fish with salt food inside your food, don't need to come put salt for your food again. You understand? So that's how they normally do it. No need to put salt in the food. It's that fish that will be your source of salt and also your source of protein in the food. Just like that. That's so that they cook for olden days. Alright. So how does salt help in preservation? Remember osmosis and microorganisms or unicellular organisms. What does osmosis have to do with unicellular organisms? What? Remember, the vacuole in unicellular organisms help them what? Excrete excess water. It's like it controls, it helps in osmoregulation in the cell. So when you subject a unicellular organism to an environment that is more concentrated than its cell, what happens? It begins to shrink. Because the environment is more concentrated than its what? Its cell. It begins to what? Shrink. It shrinks, eventually the cell dies. So that's how you know that when food starts decaying, or when food starts getting bad, it's as a result of the action of microorganisms. Okay, so when you can't add salt is very concentrated, more than the cell of those unicellular organisms, those bacteria and so on. So when bacteria can't go decompose the food, what happens? Their cell begins to shrink because of the difference in concentration, and eventually they die off. So that's how preservation is achieved through salting. All right. Salt is also used as industrial raw material for different industrial processes. Salt is used to make polish. Salt is used for bleaching. Salt is used for hardening. When manufacturing soap, saponification. If you want the soap to be hard, you add salt. It makes it hard, and so on and so forth. A lot of industrial process, baking, bread, making of bread, different things. You salt get plenty application. What is the test for sodium? We already treated this before. Metals and their flame test. Okay, the test for sodium is done through a flame test, whereby after burning the metallic ion, you are going to see a yellow flame. So sodium burns with a yellow flame. So the yellow flame confirms the presence of sodium or sodium ion. Now let's look at the alkaline earth metals. And the alkaline earth metals, the one that was selected by Jamb is calcium. And we are looking at calcium oxide. First of all, calcium oxide, how is it gotten? What is its occurrence? It's gotten from heating seashells. Okay, when you heat seashell contains limestone, and when you heat seashell, it decomposes to form calcium oxide plus carbon 4 oxide. The next compound we are looking at here is the calcium hydroxide, which is also called slake lime. It is used in mortar, to manufacture mortar. It is also used to soften temporary hardness of water, the process called the Clark process. All right, now let's look at calcium triisocarbonate 4, which is the limestone. Limestone is used as marble, and you know that limestone occurs naturally. It is used to manufacture limestone and marbles. All right, cement composition. Jamb says you should know the composition of cement. Okay, the composition of cement is 3 chemical compounds. Okay, namely calcium oxide, silicon 4 oxide, and aluminium 4 oxide. These three of them. Okay, that's what makes up the cement. The cement we use now. These 3 compounds they inside. No filler. Mortar setting. How do we set mortar? Calcium hydroxide is reacted with carbon 4 oxide to form limestone. Calcium hydroxide is reacted with carbon 4 oxide to form limestone. That's how mortar is set. All right. Now, what is the test for calcium 2 ion or calcium ion? It's still done with the flame test because it's a metal. Okay. What happens? Okay. When you burn this metal in question, because we are testing for the presence of calcium, you are going to get a brick red flame. So when you see a brick red flame, that confirms the presence of calcium 2 ion. Still under the alkaline earth metal, we are looking at aluminium. Hope you know why they are called the alkaline earth metal. Hope you know. Because they dissolve in water to form alkaline solution. What is the extraction of aluminium? Extraction of aluminium is through the purification of bauxite. Bauxite is the appearance, one of the appearance of the natural appearance of aluminium. Okay, it consists of about 3 elements. Okay, so ensure to know what bauxite contains. Okay, bauxite. Okay, so ensure to know. Go and look at your textbook, bauxite, or just search on AI sharp. All right. So this is an electrolytic process, and it involves the electrolytic reduction, which is also called the Hall-Heroult process. The Hall-Heroult process. Okay, the formation of aluminium through the purification of bauxite. All right, electrolytic reduction. What are the properties of aluminium? Aluminium is light. It is strong. It resists corrosion. Oxide layer. That's why it's used for galvanization. That's why aluminium can be used to electroplate another metal. Okay, to cover the metal in form of cathode protection, preventing the elements that cause corrosion. All right, or the element that has to be present in order for corrosion to occur. So it's preventing contact. All right. So what are the uses of aluminium? Aluminium is used to make aircraft. Aluminium is used to make cooking utensils. Aluminium is used to make electrical cable, that's wires. Aluminium is also used for packaging, like aluminium foil. We will not put we will not package things, we will not put cake, and so on and so forth. Aluminium is also used to manufacture alloy. Yes. Have you heard of Alnico? Aluminium is also used to manufacture Alnico, alloys such as Alnico, for example. Alnico contains how many elements? 3 elements. Yes. What are they? Drop it in the comment section. Alnico. All right. We already treated that before. So if you haven't looked at our lecture containing all alloys and their components, all alloys, their uses and their components, go and take that lecture. Look at the playlist. You are going to see them there. All right. So what is the test for aluminium ion? What is the test for aluminium ion? Just add sodium hydroxide or caustic soda to the solution in question and immediately the solution turns white, a white precipitate that dissolves in excess sodium hydroxide solution. That indicates the presence, or that confirms the presence of aluminium ion. How do you do it? Add sodium hydroxide to the what? The solution in question. All right. After that, if you see a white precipitate that dissolves in excess sodium hydroxide, that confirms the presence of aluminium ion. Still under the alkaline earth metal, we are looking at tin. What is the extraction of tin? Tin is extracted from calcirides, okay, which is what? Tin 4 oxide, all right? And tin is SN. SN, that be the what? The symbol of tin, SN. And this extraction is done by reduction with carbon. So you use carbon to reduce calcirides to tin, all right? You use carbon to reduce calcirides, which is this, to tin. What are the properties of tin? Tin are soft, they are malleable. We already taught malleability. Means that it can be folded, okay, or it can be hammered into sheet, all right? Tin resists corrosion. That's why it is used for alloy. Tin is also lustrous. It has a fine where it shine, it's shiny. So what are the uses of tin? Tin is used in coating, to coat cans. You use it to coat cans. Number one, for safety. Maybe you want to do canned malt or canned juice or canned drink, and you don't want to use complete tin because tin is expensive. You don't want to use tin, so you can use another metal that is cheaper. Then use tin to coat the interior where the drink is going to come in contact. All right, because tin is safe. Using tin to put your food or what you are consuming is not dangerous because tin doesn't easily dissolve in food substances. All right, so that's why tin is safe. It's not that when you consume too much tin, you carry tin now, they chop, it no go affect you. No, I mean using it for preservation. It's safe to use it to store food substances. All right, whether cooked or uncooked. All right. So what is the color of tin? Let me ask you. Tin is whitish in color. That's the color of tin. It's whitish in color and it is lustrous. Okay. Tin is also used as alloy. It's used to make alloy. For example, bronze and soda. What is the component of bronze? Let me ask you. The alloy bronze. What is the component? Do you know? If you don't know, take our lecture. Let me just tell you. I mean, nobody like say, don't get the one why I tell you. Bronze contains copper and tin. All right. Copper and tin. That's what bronze contains. That's what makes up bronze. What about soda? What does it contain? It's an alloy. What does it contain? It contains lead and tin. Let's quickly look at transition series. Okay, transition metal. They are also known as the first series. What are the characteristics of transition metal? First of all, before we look at the characteristic property of transition metal, let's understand why they are called transition metal. They are called transition metal, or they were given the name transition metal. Why? Because they are metals that never existed at the early time. Okay, so they left space for them in the what? In the periodic table, and they named that space transition metal. That means any metal that is discovered from now henceforth is going to be placed here as a transition metal. Okay, it's a transition into the periodic table. They didn't exist before. Okay, they never existed before. So as they continue to discover them, they started bringing them into the periodic table, and under the column left for them called transition metal or transition column. All right. So the characteristic property of transition metals include variable oxidation state. They get many different oxidation states. For example, iron 2 ion, iron 3 ion, and so on and so forth. The second characteristic property is that they form colored ions. They form what? Colored ions. For example, you have copper 2 ion, which is blue, and you have iron 3 ion, which is brownish. The third characteristic property is that they form complex ion. All right, not just colored ion, they form complex ion. What are complex ion? Complex ion are forming complex with more than one element. All right, forming complexes with more than one element. For example, look at this complex ion here now. This complex salt we did here now. Complex salt of copper. Can you see it? It's a complex ion. This is a characteristic property of transition metal. The transition metal that did this or that's responsible for this is copper. All right. The fourth characteristic property is that they are used as catalysts. They can act as catalysts. Okay. For example, iron in the Haber process, vanadium 5 oxide in the what? In the contact process. Okay, and so on and so forth. So for their electron configuration, they have a partially filled d orbitat. All right, or partially filled d block. All right. So these are the characteristic properties of transition metal. Put them inside your head. Don't say I don't tell you. Now that we've understood the properties and the uses of metals and their compounds, understood transition metals too, let's now look at some Jamb must repeat questions to test the knowledge we acquired so far, and also, measure how prepared we are, our preparedness for Jamb UTME 2026. Jamb must repeat questions. Question 264. Which of the following is a general property of metals? A. Poor conductor of electricity. B. Brittle. C. Malleable. D. Non-lustrous. What's the answer? I taught you just now. Drop the answer in the comment section, my scholar. Question 265. Which process is used in production of sodium hydroxide? A. Haber process. B. Contact process. C. Electrolysis of brine. D. Solvay process was the answer. I just thought you, please don't disappoint me. Drop the answer in the comment section, my scholar. Question 266. I know you are a scholar. This is moi. Which ion form precipitates with sodium hydroxide that dissolves in excess? A. Calcium ion. B. Aluminium ion. C. Sodium ion. D. Iron was the answer. Drop the answer in the comment section, my scholar. I taught you now. Question 267. Which industrial process produces sodium carbonate? A. Solvay process. B. Haber process. C. Contact process. D. Oswald process was the answer. I know you know the answer. Please don't disappoint me. I just taught you this thing now. Drop the answer in the comment section for me. Question 268. Which compound is used in the manufacture of glass? A. Sodium chloride. B. Washing soda. C. Copper oxide. D. Aluminium oxide was the answer. Drop the answer in the comment section, my scholars. I already taught you now. Don't disappoint me, yo. Question 269. Which flame test give a brick red coloration? A. Sodium ion. B. Calcium ion. C. Potassium ion. D. Barium ion was the answer. Give me the answer in the comment section. You are a scholar. Question 270. Which compound is obtained by heating seashells strongly? A. Calcium tricarbonate 4. B. Calcium oxide. C. Calcium hydroxide. D. Calcium chloride was the answer. Drop the answer in the comment section. I just taught you this question now. You are a scholar now. Please give me the answer in the comment section. Question 271. Which of the following is the main chemical composition of cement? I tell you, say Jamb will repeat this question. They always repeat that. They make them put up on their syllabus. Tell you, say, know the composition of cement. You A. Is it calcium oxide? Blah blah blah. B. Is it blah 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 blah. C. Is it blah 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 blah. D. Is it blah blah blah. What's the answer? You are a scholar now. I know you now. I've seen you before now. Please drop the answer in the comment section. Question 272. Which ore is the main source of aluminium? A. Cassiterite. B. Bauxite. C. Hematite. D. Galena. What's the answer, my scholar? I just taught you this thing now. Don't disappoint me. Let me have the answer in the comment section. Question 273. Which method is used for the extraction of aluminium? A. Blast furnace reduction. B. Electrolytic reduction of alumina. C. Roasting and smelting. D. Thermal decomposition was the answer, my scholar. I already taught you all these. It's very easy. Can you please give me the answer in the comment section? Question 274. Which ore is the main source of tin? A. Cassiterite. B. Bauxite. C. Magnetite. D. Chalcopyrite was the answer. I know you know the answer to this question. I just taught you not quite long ago. Please drop the answer in the comment section. Question 275. Which property is characteristic of transition metals? A. Fixed oxidation state. B. Formation of colored ions. C. Poor conductivity. D. Non-metallic nature was the answer. I just taught you this thing now. Just drop the answer in the comment section. Question 276. Which transition metal is used as a catalyst in the Haber process? A. Is it copper? B. Is it iron? C. Is it nickel? D. Is it vanadium? Was the answer. I know you know the answer to this question. Please drop the answer in the comment section. I taught this in a simplified way. Do not disappoint me, please.